Okay, we're back to influential points. We've already talked about this in this unit, but we're going to get a little bit more specific because there's two kinds of influential points that you can have. So, an influential point is any point that, if removed, substantially changes slope, y-intercept, or correlation. The key here is it has to be a significant difference. Sometimes you'll see it worded as significant. Sometimes you'll see it worded as like sharp. It affects it sharply. And if it affects the slope or the y-intercept, that is called a high leverage point. And if it affects the correlation, that is usually referred to as an outlier. When I went through and did your Can You Do for this section of the lesson, at first I was having you guys identify if it would be considered high leverage or an outlier. And by the time I was done, what I realized is it's way more important for you to understand how it affects slope, y-intercept, correlation, all of that stuff, than to identify it as high leverage or an outlier. So I will explain to you what those mean, but if that is a lot for you to keep track of, just focus on what happens to your important numbers. So the AP board actually has a really good video for this. So I think that I will play their explanation and then we can go through our notes. Their explanation is actually very quick. Oh no, I was in the student place. Do you guys ever go into AP classroom? No. No. Do any of your teachers use AP classroom? Oh, cool. Cool. I'm just skipping to the part I want.
High leverage points, the least squares regression line, in terms of the slope and or its y-intercept, can be meaningfully changed. So that's how we define high leverage points. Those are points with unusually large or unusually small x values, i.e. far away from x bar, the mean of our x values in our data set. And if we remove them, they usually will have a large effect on the slope, the y-intercept, or both of our least squares regression line. So what about this point right here? Here's a very simple example, just here's 6 data points. And we can see here's our least squares regression line for these data points. And this point in green towards the bottom, what kind of point is that? Well, it's close to the mean of our x variables, So it's not necessarily a high leverage point because it's very close to that mean point. But it does still appear unusual. So how can we still categorize it? Well, let's look at the residuals from this least squares regression line. We can see the residuals all look to be similar in magnitude except for that green point. This has an unusually high magnitude residual. And we call this, when you see that, an outlier. When it's an unusually high magnitude for its residual. And this will have a big effect on the strength of this relationship. Point is not included. And in addition, the coefficient of determination value, the R squared value, is all.
So going back to this idea, if the residuals for this line in orange, you guys can see that those residuals are not very large. And then you add in that green point, and it has a residual that's like almost three times as big as all of the other ones. So is this going to increase S or decrease S? So remember, S is the average residual. By how much will we be off by? So is this going to increase our typical residual size, or is this going to decrease our typical residual size? It's going to increase S. S describes how large your residuals are. So if you add in this point that has a very large residual, you are now going to increase your prediction error because you've added a point that's way farther away from the regression line than any other point. And that point represents, or that point has a difference between your prediction and your actual that is very, very large. Play.
Will have a big effect on the strength of this relationship. To see what I mean, here is the least squares regression line with that point included and without that point included. You can see here the correlation value is much higher when that point is not included. And in addition, the coefficient of determination value, the R squared value, is also much higher. So you can see there's a big effect on strength from removing that point. So these are all types of influential points, to sum everything up. Influential points are points that, if removed, change the slope, the y-intercept, and or the correlation substantially in our model. So there are three types of influential points. There are outliers, which tend to change the correlation. There are high leverage points, which tend to change the slope and or y-intercept value. And there are points that are both. And those are also considered influential points.
Okay, so I didn't talk much about the influential points that are high leverage because we've seen this before in this exact example. So up at the top, we have the original information. We have our regression line. Our strength is not very high. It's only 41.41. And our amount of the variation in Y that is predicted by X is only 17%, which means that 83% is not explained. S is 2.77. We have seen this example right here where if we add in this point way far to the right, but in the pattern, what ends up happening is your R increases by quite a bit. It goes from 0.41 to 0.94, and the reason why is because it's in the pattern. Well, if R increases, R squared also increases. So this guy, he says that you have a high leverage when it is far from the other points in the X direction. That can be to the left or to the right. So this can be unusually high or unusually low X values. It can be unusually high or unusually low X values. The point that was added is very close to the regression line. So notice that your standard deviation of your residuals decreases slightly. This is like almost right on your regression line. So this will decrease the average size of your residual. Is this making a little bit of sense? Y-intercept and slope did not change because it is in the pattern. It didn't affect your line because it's basically right on the line. It's doing nothing to change it. However, let's add in a point so that we can see what kind would change our slope or y-intercept. If you added a point down here, this would change your values. This point here, if we had A, which is y-intercept, and B, which is slope, slope would decrease. I think that y-intercept would increase slightly. The reason that I can see that is because if I sketch in a line that now accounts for this point down here, it's going to look more like this. It's going to be a flatter line. And to accommodate for the different slope, it's going to need to go through X at a different point. That's probably a better situation. So if you need to and you have the graph available, you should draw in the new line to get an idea about what would happen. So remember, A is y-intercept, if you forget, and B is slope. So in this case, it didn't change regression line because it's right next to it. In this case, it would change your regression line because it's not in that same pattern. I added a point that was slightly below the regression line. Are you okay there?
Yeah.
Thank you. Okay, next one is another high leverage, but he's totally not in the pattern. This guy changes your slope substantially and your y-intercept. Look at how different they are. Slope goes from 3 to almost 6. Sorry, y-intercept goes from 3 to almost 6, and slope is a completely different sign. So this is a really good example of how a high leverage point can truly have a substantial effect on your regression line. R decreases, because really without that point, this relationship should be positive. And now because of 1 point, it's negative. So R is not as strong, which means even less of the data is explained by X. So that all has a big effect. Now S is a little bit weird in this one because S above in the original is 277, but down here it's about the same. And the reason why is even though we added a point that completely changes the line, he's still close to the new regression line. So you would say that 277 and 289 are about the same. They're about the same. And the reason why that happened, so I guess I should note that that goes with S, is even though the new point has a relatively small residual, the standard deviations got a bit bigger because these distances from the line changed a little bit. So if you look at these distances from the line compared to these distances from the line, there's a slight difference. You would not be described to ask S in this situation or answer how it changes S. Whatever point they give you, it will be an obvious change. You won't have to sit there and think, oh, I don't know if it'll increase or decrease. So on this one, as long as you feel good about what happens to the top three, your understanding is fine. Then the last one is this idea of an outlier. So he's over here, he's not in the pattern, and he has a very large residual. So from the prediction line, he's way farther away. This is not an unusual X value though, because all of our data points are right around 5 and below. So he's in, his X value is okay, his Y value is way too high. And that's what this says. It says a point that is far from other points in the Y direction is an outlier. In this case, notice that it pulls your line up. So essentially, you keep the same exact line, but it gets closer to the point that you added. And that one, this line is not, would not be the real line, because we know that the y-intercept is 6 and mine's at 14 or 13. I'm just trying to illustrate to you in an exaggerated way that that point is going to pull your line toward it. It's not going to change the slope because the X value is about the same. It's going to change where your y-intercept is. Your relationship, the strength of your relationship is much weaker now. And the amount of variation that is explained is way less. 1% is explained by X. And then lastly, hopefully, as you would expect, standard deviation increases a bunch. Standard deviation of the residuals goes from about 3 to 11. The most that you'll learn about influential points is by actually doing problems on influential points. So we're going to do a couple, which is part of your Can You Do, and then we are done. So while I bring you your Can You Do, I want you to go to staplet.com. I'll write that up. STAPPLET.com. That stands for a stat application. We're going to page 419 in your Can You Do. So when you get it, you're going to the second page. These are your Can You Do's for the rest of this unit. So it's a thick packet. Don't be alarmed. Okay, so usually when we talk about influential points, we are talking about what would happen if you remove the point. So further on, actually it's not further on. In your lesson quiz, it asks you what would happen if you removed the point. To investigate what really happens though, we're going to practice adding some points. So this is, we're going to add points in this problem. But usually when you're asked questions, it says what happens if you remove the point. So on Staplet, click on 2 quantitative variables. It's under data analysis. Toward the bottom, 2 quantitative variables. Now, our variables don't have names, so we don't need to name them. But in the explanatory, you should enter in these values. So 2 space, 2 space, 4 space, 4 space, 5. Then in your y, you're going to add in 3 space 5 space 4 space 7 space 6. Hit begin analysis, and it gives you the scatter plot. If you do calculate correlation, I get an R of 1. What do you guys get? Do you get 1? Okay, so I'm getting 1 because I need to go down to the bottom here. And I need to change my setting to rounding numbers. I need to change it to 3. Mine is on 0. And then down at the bottom, if you hit done, that should, if I rerun this, that should fix it. I'm going to hit edit inputs and begin again and calculate. So 589 is what I'm getting now. So if you needed to fix that, you scroll down to the bottom menu and adjust your rounding. That's this second box. Then it says calculate the least squares regression line. You hit that and it will add the line to the scatter plot for you. So what you see in black on this scatter plot on your paper is the scatter plot and the relationship between these 5 points. That is described by this equation. It asks you to fill in that information on your worksheet. So up here at the top, the regression line equals, I'm going to round to 2 places, 2.64 plus 0.69 x, and my R value was 0.589. So this is above that scatter plot on 419. If you look in this little box here, notice it gives you S and R squared. S you cannot calculate, but R squared you could have gotten from squaring 589. Okay, so down below it says what happens if you add the point, and in this top line, this is the original data. So I have put in your R and S, slope, and R squared. I've added in all this data for you. So the very first one is asking you what happens if you add 4, 5. So to make sure that we all understand what's happening is, I'm going to add in this new point, and I'm switching over to Desmos so that everything else stays the same. So I just added in the orange point. What will happen to all of your values? Well, let's look at what happens. Your residuals, the average of your residuals decreases. Why? Because this new point is so close to your regression line. R is about the same because it's by your line. So 589 and 577, that's about the same. Slope is about the same because it's so close. This point that I added is so close to the line. And R squared, if R is about the same, R squared is about the same. Is this making a little bit of sense? Yes? Was that a yes? Okay, so 8, 8 is letter B. That's this guy here. Predict what will happen to these things. So you, before we run this, write in these symbols. Arrow up, arrow down, or about the same. Predict it before you actually plug it in. I'll give you like 30 seconds. So you're looking at B. You got about 10. Three. Okay, my predictions were S will decrease because B is basically on the line. R increases because he's an outlier in the pattern. B is an outlier in the pattern, so R increases. Here, R didn't increase because it was not an outlier. It was in the pattern, not an outlier. Slope, I think, will be about the same, and R squared will be the same. Oh, I lied. R squared is not the same. What happens to R squared? It'll increase, and I know that for sure because R increased, and I put that in for you. So now it wants to know the new regression line, and that can help you answer these questions. So to do that on Staplet, you can go back up to your inputs and add in 8 for your X value. So you have to press space 8. Then when you click down in the Y, it's going to say, are you sure that you want to change your scatter plot? Just hit OK, space 8, begin analysis, and then you can run your correlation and your least squares regression line to see what the new model would be. So down in your equation, it changes to y hat is 2.73 plus 0.66x. We predicted that S would decrease, and it did. It went to 1278, the same as before. R, I gave you. Let's just make sure I wrote in the right one. I did. Slope was about the same. It's 0.66. R squared, 626. So it's double. Do you guys see what's happening here? Let's do one more. Let's see. Do you want to do E or do you want to do G? Let's do E. So go to E and predict what you think will happen in these boxes. So on E, make a prediction. I'm going to walk around and make sure that you did. And once you have that, if you want to try adding in this point, so you can make sure that you know how to do this, you can. So you're predicting what will happen if you add the point E. How come none of you guys are writing this in? All you have to do is write an arrow and a squiggly line. On E, write them in. Is slope going to increase, decrease, stay the same? S, R squared, move your pencils. Good heavens, 18 kids. Okay, so to change our info, you got to take off your last one that you put in. So I got to take off the 8 and put in a 1. Do I want to change my scatter plot? Yes. Take off this 8, replace it with a 7. Begin analysis, calculate your correlation, calculate your line. So this line for E is y hat equals 5.08 plus 0.08x. What will happen to S? It'll increase because E is far away from the regression line. It goes to 182. The correlation decreased because you're adding a point that is not in the pattern. So the strength of your relationship decreases. Slope decreased. It went to 0.08. R squared decreases. It's way, way small. So on this chart, this is supposed to help you get a really good idea about what will happen to these things, and you will get the most out of it if you make predictions first. You should really go through, look at the points, predict, and then see if you were right. If you go to the next page, I think that you'll be okay on this one. On number 5, you just need to circle the effect. If you look at your lesson quiz, I just want to highlight that the questions ask you what happened if you remove the point. So you have to think about what the graph would look like without the point. Does this make sense what I'm saying? So on this one problem in Canvas, this is the regression line with the outlier. This is the outlier. You describe how would this line change if you took this point out. The same with the next one. It doesn't give you the line, but you can imagine it. And it says what will happen if you take A off of the graph. So make sure that you know the distinction. On your can you do, you're investigating how do these points affect your values by adding it. On this one, on these quiz problems, you got to think about how will the line change if you remove it. So if you remove this point, you have to envision that the line for this scatter plot is going to fit better. Okay, you have about 15 minutes. You can spend that time doing your lesson quiz or finishing. I would do your lesson quiz or finish this Statlit problem so that if you have questions, I'm here to help you if you need it. Do you all understand what you're doing? Yes. Yes, I know the recorder is recording. How do I get it to stop recording?